Spectroscopes. The most common technique to analyze visible light is known as spectroscopy. This involves splitting visible light into its individual colours or wavelengths, and to do this we use a spectroscope. We have two different types of devices today. A spectroscope is used by looking through the eyepiece and observing the spectra of a light source. This is good for displaying the continuous spectrum of white light and visualizing that it is made up of many different wavelengths or colors of light. A digital spectrometer allows us to analyze more accurately the intensity of each particular wavelength of light and how this changes as we alter the brightness of the bulb. So let's turn on our bulb and use both devices to investigate the light that is emitted. So we're going to look through the eyepiece here and hopefully see a continuous spectra through the spectroscope. Looking through the spectroscope, we can observe a continuous spectra of the short wavelengths of blues and violets on the left to the longer wavelengths of reds on the right. Hopefully that's clear to see. Now we can use our digital spectrometer and point it at the light source. We can then use a software program to analyze the emitted wavelengths. We're going to turn our bulb down to 2 volts and have a look at our software to investigate the emitted wavelengths of light. So at 2 volts, with a very dim light, we get equal intensities of all wavelengths, all around 1. We can then turn the bulb up to 6 volts and do the same thing again. At 6 volts, the bulb is brighter, and we can see that the intensities are skewed to be larger at the red end of the spectrum here. So larger intensities in the red end of the spectrum whenever the bulb is brighter. Finally, we can turn the bulb to 10 volts to analyze. Here the bulb is brightest, and we can again see a more dramatic increase of wavelengths towards the red end of the spectrum up here. We can compare the 3 voltages, if I adjust the scale. So the bottom is 2 volts, middle is 6 volts, and then most dramatically is the 10 volts. For each increase in voltage, the intensity of light for all wavelengths increases. However, this increase is more dramatic for longer wavelengths towards the red end than it is for shorter wavelengths near the violet end.